Today we're going to do a Hello World C programming tutorial. It's going to have multiple parts. Some things you should learn before you start programming are binary, hexadecimal, ASCII, converting decimal to binary, binary to hexadecimal, adding and subtracting, and so on. We'll be going over the basics of how the compiler works. Now let's get started. Okay, first you start out with your source code file, hello.c. It goes through the preprocessor. The preprocessor copies the header files into the source code file, generates macro code, and replaces symbolic constants defined using pound define with their values in the expanded source code file. Okay? And the expanded source code file is hello.I. You can generate a hello.I by using gcc -e hello.c and output it to hello.I. Then it goes through the compiler stage. It takes hello.I, then it generates a hello.s file, which is an assembly source code file. Then it goes through the assembler. It takes that hello.s assembly source code file and generates an object file, hello.o, which is a machine code file. Then it goes through the linker. The linker links the object code with the library code and produces an executable file. Hello. We're going to go through this in code and I'll show you some examples. First we're going to create hello.c. Save it, compile it the standard way, run it. Let's get back into the file. I want to briefly go over what each of the lines of code do. We'll go into it in greater detail in part 3. It includes a header file, stdio.h, and you need that so you can use printf. Int main void, int main returns an integer. Void, no arguments, return 0. It returns 0 back to your operating system. And as I said, we're going to go into each one of these items in much detail. But for now, that's good. Okay. Now the first thing we're going to do is we're going to generate the hello.I file. And I just want to show you, what's inside of it. Now we're just going to look at the end of it because there's a bunch of stuff in it. Because stdio.h is an involved, pretty involved file. And as you can see, our code is in there. You can see some externs, some defines. Okay, and now what we're going to do is we're going to create our own header file. Now I created this file just so I can show you, what goes into the hello.I file. An example, an extern. I created a random extern that'll go in there, and our code will go in there, and you have to include it, these 3 lines of code. Otherwise, if your header file is in the source code more than one time, and then it'll put it in a hello.I file multiple times. And the way it works, if not defined, okay, it's not defined at this point, so it includes all the code in between if not defined and end if. You know, then it'll define header, you know, add extern. And so if you have header.h in your file 2 times, next time around it'll see that it's already defined and it won't include it in the hello.I file. Okay, that's why that's important to have those lines of code in your header file. Okay, we'll add it into our hello.c. Okay, I did it differently because when you create your own header file and it's not in user include, you have to use quotes and you have to add a path to it. But since it's in the working directory, I don't have to add a path. I mean, you could just copy it to user include and you could use the brackets, but I don't recommend that. You shouldn't copy any of your own header files in the user include. Okay, now we'll compile it. We'll generate the I file and we'll take a look at it. And as you can see, it included, you know, header H, extern, and all the externs from the stdio.h file and other code. Oops. Okay. Now what we're going to do is we're going to include it multiple times. We'll include it 3 times. And I want to show you, we'll create the output, hello.I. Look at it. And you can see it's only in there 1 time. Okay? Now we're going to edit the header.h file. And we're going to comment out these lines. Generate the .I file. Look at it. And we can see it's in there 3 times. Extern, extern, extern. Oops. I want to show you another file, macro.c. In this file, I have a couple of defines, num1, num2, and what happens is in the hello.I file, you're not going to see num1 and num2 in there. Sum equals num1 and num2. Num1 and num2 will be replaced with 6 and 3. But the regular variables a and b will remain a and b. And I'll show this to you. And you can see 6 plus 3, 6 and 3, but the other variables remain the same, a, b, a, b. So that's what the define does. It replaces all the instances of the define with its value in the .I file. Now the next thing we're going to do is we're going to go through the compiler phase and we're going to generate hello.s, the assembly code file. And it generates a hello.s automatically. You can see it right here. We'll take a look at it. That's the assembly code file. And GCC uses GAS to compile the assembly code to generate the object file. And you can also use GCC to do that, but we're going to compile it using AS. -O. Okay, we have a hello.o. Now it's going to go through the linking stage. GCC uses LD. If you go to link it by hand, you know, the standard way, it's not going to work because you have to use a lot of flags and you know, just a lot of different. It's just GCC knows how to do this, so we're going to do it using GCC. I'll show you. I'll do it the LD way, and just to show you. You can see we have errors, but we're going to use GCC. And there we go. Now I found this pretty cool program. It'll take the object file and create NASM code for, so you don't have to use gas. It's objconv, and we're going to do that right now. Oops, I forgot. -F. Okay, and that created hello.asm. Now before we can compile it with NASM, we have to edit a few things. It doesn't make a perfect file. The first thing we have to do, remove this. Remove this. And we'll remove this. Okay, now we'll compile it. Created hello.o. And now we'll link it. We'll use GCC. There we go. And now I have a hello.asm. It's a 32-bit file. I find the 32-bit ASM file easier to read. So what we're going to do, we'll take a look at it. We're going to compile it and link it. And as you can see in this file, we'll be able to use LD in a standard way, because it makes system calls instead of the glibc, you know, instead of a library file. It makes direct calls, and so we can bypass that, you know, which is pretty cool. Okay, so we're going to compile it. Oh, and another thing, I know, oh, forget that. Okay. Now we're going to link it. We have to use ld.gold. That's the 32-bit linker. Pretty cool. Assembly language is very cool. Okay. Now what I want to do is we're going to use the objconv on a high.o, to see how it converts that. My typing's horrible today. -O, I don't want to overwrite my file. Okay, now we have to edit it to get it to compile. Okay, now there's a few things wrong in here. Okay, first thing we have to do is get rid of this. I don't know much about assembly language, but very little, but enough to know to edit this file. We have to get rid of this. I'm going to skip one up there. And up here. Now this is a kernel call, and it's using a -128. It's supposed to use a hexadecimal value of 128, or you could use the binary value. I'll use hex up here and binary down here. We have to change that. It'll compile, but it'll have an error. We'll change it. Okay, and we'll change this one to binary, which would be a 0B. Oops. Oh man, that screwed me up. It's annoying. And let's just re-edit the file. It's easier. I don't know. Okay. Where is it? 80. Okay. Okay, 0B. Okay. And that's binary. In binary, that's 128. Alright. And now we're going to compile it. Okay, and now we're going to link it using LD Gold. Okay, and there we go. Pretty interesting. Like one rabbit hole after another. Okay. And, right, and that's it.